The second skill on page 128 is going in the opposite direction. So now I'm giving you rectangular coordinates and I want polar. So I'm starting out with the xy value and I want r theta. So I'm going to use my second set of relationships. My theta is equal to the tangent inverse of y over x, and r squared equals x squared plus y squared. So in my first example right here, theta is equal to the tangent inverse of y over x. So I'm dealing with the tangent inverse of 2 over 2, which is really the tangent inverse of 1. And the tangent inverse of 1 is pi over 4. Second part then, x squared plus y squared is equal to r squared. So 2 squared plus 2 squared is equal to r squared. 8 is equal to r squared. So r will be 2 square root of 2 when you simplify it down. So in polar coordinates, I put my r first and then my angle measurement. So 2, 2 is the same thing as 2 square root of 2 comma pi over 4. The second one we're going to have to use a little bit of analysis. We've got the point 0, 2. And if I try and use my tangent inverse of y over x, I can see I'm undefined. And there are two places that the tangent inverse is undefined. It's undefined at pi over 2 and 3 pi over 2. So you got to keep that in our mind for when we write our final answer. The second part, r squared equals x squared plus y squared. So 0 squared plus 2 squared. So r squared is 4, which means r is going to be 2. So I've got to write this in the format of r theta. So if I do that, I would first have 2 comma pi over 2. And I look at that because I know 0 comma pi over 2 or 0 comma 2 is 2 units up on the y-axis. So I'm going just straight up. So my 0, 2, if I were to draw it rectangular, is right there. So if I'm going to go positive 2, that means I had to face this direction, which is 90 degrees, which is straight up. So that's 2 comma pi over 2. The other thing is 3 pi over 2. I know that's my other undefined point, so that means I'd be facing down here. How do I get up to that point? Well, I've got to go negative 2 back. So both of those are legitimate answers for converting 0, 2 into polar coordinates. I don't give you any restrictions on where tangent inverse has to be, so I've got to look at both answers. The third one, negative 1 comma 0. This one will have the tangent inverse of 0 over 1, which is the tangent inverse of 0, which we could say that's 0 pi. We also know the tangent inverse of 0 occurs at pi. R squared equals x squared plus y squared. So r squared is negative 1 squared plus 0 squared. So r is going to be 1. So if I want to look at this, I know my rectangular coordinate is negative 1 comma 0, which is that point out there. So if I'm going to use 0 pi as my angle measurement, that means I'm facing this way, which means I have to go negative 1 back. But if I use the positive pi, that means I'm facing this direction, and it's a positive 1 unit out. The last one right there, the tangent theta equals 1 over negative 1. Actually, negative 1 comma 1. I'm getting ahead of myself there. I'm going to take the tangent inverse of y over x. So the tangent inverse of negative 1. We know negative 1 is going to occur in the fourth quadrant, which would be our negative pi over 4. Then we'll use our r squared equals x squared plus y squared. So r squared is negative 1 squared plus 1 squared. So r squared is going to be equal to 2. So r is equal to the square root of 2. So square root of 2 comma negative pi over 4. Now, some of you are probably saying on these two problems, couldn't I have done the exact same thing, saying, well, here, tangent inverse of negative 1 occurs in both the second and the fourth quadrant. Couldn't I have created another ordered pair right there? And the answer is absolutely. Same thing over here with pi over 4. Doesn't tangent create a pi over 4 in both the first and the third quadrant? Absolutely. I could have done the same exact thought process as I did on these two and expanded it out. Really, the one we look at dealing with where we've got to have both answers are the undefined cases, because when we looked at tangent inverse originally, it's only defined in the first and the fourth quadrant, and this is the borderline of that first and the fourth quadrant, which isn't included in the domain. So we want to look at both of those answers. Technically, for this one right here, since I was defined in the first quadrant for this 0 pi, I only needed this first answer. I didn't have to get that one, but just showed you that you could come up with that answer as well. So realize that for all these, you could think big picture, anywhere in the unit circle, where would tangent inverse be defined? And all these could come up with two solutions, or even more if you look at reference angles on the unit circle.